And welcome to CSIT 165 Module 3. In last week's module, we covered R Markdown for formatting and presenting analysis to turn in homework assignments, lab projects, and group projects. For this week, we'll cover version control with Git and GitHub. So, what is GitHub? Well, data scientists and computer programs never operate in vacuum. That is, we collaborate with others on projects. Project collaborations can be tricky, however, because we aren't operating from one document, but instead are using many, which may consist of datasets, scripts, and other files that are necessary for project analysis. Here we explore how to use Git and GitHub for collaboration on data science projects. GitHub will be the primary method that you will collaborate with others on team projects. For this week, we'll be doing a few things. The primary thing that we'll be doing is to read our two books, Programming Skills for Data Science and R for Everyone. In Programming Skills for Data Science, we'll be reading chapters 3 and chapters 20. In R for Everyone, we'll be reading 2.2.1 and 2.2.3. This week, we will also have a discussion. This discussion will be pertinent to Git and GitHub, but will have a very similar style as Graded Discussions 1 and Graded Discussions 2, in that it will be due on Saturday at 11:59 p.m. It'll have 3 prompts that you'll be needed to respond to, and you will also be given 2 replies to those 3 prompts in order to receive full credit. The rubric is also listed in Discussion 3 as it was for the last 2 weeks. This week's exercises will be going over programming exercises for Git and GitHub. Namely, we'll be going over configuration, forking and cloning, adding files to a staging area, committing those files, pushing those files to GitHub, creating new branches, switching between branches, merging, and resolving merge conflicts. These exercises will primarily be focused on terminal applications of Git and GitHub. Terminal applications for Git and GitHub are very necessary, as mistakes do happen when you're working and collaborating with others, and oftentimes the best way of reverting back to older versions of your project is at the command line. As well, I believe that the command line is absolutely essential to really understanding how Git and GitHub work. And these exercises will be paramount to your ability to work on group projects in the future. In this video, we'll be covering a few different basic things that aren't covered necessarily in those exercises. First of all, we're going to go through and actually create a repository on GitHub. Before doing so, though, you'll need to establish a GitHub account using a username and password, as well as your associated email address. The email address that you should use should be the Palomar email address that you are given as a student. As well, after we create this repository, we'll clone this repository in RStudio, make changes to some file, commit those changes, and push those changes to GitHub. After we push those changes to GitHub in RStudio, we'll view those changes in GitHub to see that we actually have done so. So let's get started. This is my GitHub page. You'll have your own GitHub page when you create a GitHub account. In order to create a repository, we'll click on Repositories. You can see that I have one repository already. It's called CSIT 165, and it's set to private mode. When it's set to private mode, it means that nobody will be able to view it and nobody will be able to make changes to the files that are inside of that project. When you're working with others on group projects, it's best to set the mode to public mode. When you set it to public mode, you'll be able to collaborate with others to actually work on group projects. When you do work on group projects, there are a few different ways that you can collaborate with each other. You can use branches, as discussed in Chapter 20, or you can use a centralized workflow that'll use many of the concepts from Chapter 3. Using a centralized workflow will be easiest, especially if you guys are working in smaller groups, which you will be for this class. So let's go ahead and make a new repository. To make a repository, simply click New. When you come to this page, you'll be prompted to make a repository name. For my example, we'll call it CSIT 165. This repository will be set to the public mode so that anyone can view it. When anybody can view it, that includes all of you. However, if you cloned this repository and attempted to commit and you made changes and you attempted to commit those changes, you will not be able to commit those changes, or rather push those changes, unless if you are a collaborator. We'll go into that in a little bit. But when you're working with others, it's important to make sure that you set your collaborators as the students that you're working with. That way, you can all make changes to the files, you can all view them, and you can all view the messages that accompany them. So we will be initializing this repository with a README markdown file. This is necessary, or at least it's encouraged if we're not importing an existing repository. Let's go ahead and let's create this repository by clicking Create Repository. After we create the repository, we'll notice a few things. Inside of this file, or this section, it'll show the files that are within that repository. This repository is pretty bare because we haven't really done anything with it yet, but we do see that we have that read markdown file that we used, that we initialized with. Within that README markdown file, we see that it says CSIT 165. It's the title of our repository. To get this repository, or to clone this in using RStudio, not using the command line, but using the GUI interface, let's go ahead and click Clone or Download. Once we do that, we can click on this button, or we can highlight the text to copy it to our clipboard. After we copy it to our clipboard, then we go ahead and we go to RStudio. Once we're in RStudio, let's create a new project by clicking on this icon. When we click on that icon, we'll choose Version Control, Git, and then we'll go ahead and we'll copy and we'll paste that URL into the repository URL. When we do this, we'll also be prompted with a project directory name. It's best to leave the project directory name as whatever that repository was, but in my case, I'm going to name it student because I have two of these with the same name. When we go ahead and we create the project, make sure that the subdirectory is located where you would like to operate from. In my case, I'm operating from CSIT 165. This is the same directory that it used to make all of the labs and group projects, as well as all the exercises for this class. Let's create project. When we create the project, we'll notice a few different things. First of all, we'll notice in the bottom right-hand panel that we're in the directory student of CSIT 165, and that we have three files. We have the student.rproj. This is because we created an R project, and RStudio makes a file for the creation of that R project. We have the readme.md, which when we click on it, has a hashtag CSIT165. This is the name of the repository. The hashtag is making it to create a header, as you learned last week. The reason why it's so bold in this is because it's actually a header in the markdown. We also have a gitignore. What gitignore does is it chooses that when you specify what is on gitignore, and it comes default with rproject.user, the history, whatever data, and R user data, anything that's usually formatted while you're working in an R environment, or that's automatically kind of saved there. By including this in the git ignore, it makes it so that other people can't see what you were doing can't view those files, or rather that when you do commit or you push those different files that you made changes to, these specific files that end in this suffix won't be appended. Another thing you'll notice when you create an R project using version control is that you no longer only have environment, history, or connections, but you also have a file called Git. When we click on Git, it shows the different files that you have to be available to commit and to push from. Let's make a new file and let's see what happens. In our terminal, we'll make a file called test.txt. In this file, we'll have it say, this is a test. We will create that file using test.txt. If you're unfamiliar with how I've done this, please visit Chapter 1 so that you can become more familiar with terminal or command line tools. It looks like that did not work correctly, so we'll go ahead and we'll start a new terminal. And we'll do the exact same thing. Let's say echo, this is a test, test.txt. And when I create that new file, test.txt, you can see that we also have a file here that says test.txt. The reason why the file was created here was because this is the working directory that I'm in. To see that I'm in this working directory of home, public, RStudio, CSIT, student, we can use pwd for print working directory. Yep, that's the same. That's why test.txt was saved in this file. Another thing that you might recognize is that test.txt is also now in Git. That's because we added this new file. It's available to commit and to stage, commit, and to push. To stage this file, let's hit commit. After we do so, we'll highlight all these files, then we'll click stage. Once we stage, you can see that it has a check mark upon each one of them. Stage is analogous to the terminal of add. After we do so, we can make a commit message. It's important to use a commit message that's actually meaningful and that shows what kind of changes you made to those different files. That way, as a version control system, if you wanted to ever revert back to a different or prior stage of your project, you can always revert back to it or find your way back to the correct version by using the messages from the commit messages that you use. We'll say created test.txt document, and we will go ahead and we will commit this. When we commit it in RStudio, it'll tell us exactly what files were changed and how they were changed. It says that we had 18 insertions. What this means is that we created 3 files with 18 lines and we inserted new information into those lines. Let's go ahead and let's close this. Next, you'll also notice that now it says your branch is ahead of origin/master by 1 commit. Using the terminal, we can see this as well when we hit git status. It tells you what branch you're on. We're on master branch, but we can also change that in RStudio by switching branches. However, there are no branches here to be made, but we can create new branches using this icon. The git status will also say that we are ahead of origin master by 1 commit. It says to use git push to publish your local commits. Nothing to commit, working tree clean. We can do that using the terminal, which will be discussed in your exercises, or we can also do that using the GUI interface of RStudio by clicking push. Once we push these changes to RStudio, we should see those changes reflected in GitHub on the website. Going back to GitHub now, we'll refresh this web page. And now you can see that we also have this new test.txt file. When we click on that, it will say this is a test. That's great. We have successfully made a file, made changes to that file in RStudio, and pushed those changes onto GitHub using the GUI interface. The GUI interface is great, especially if you're really committed to working with others and if you want something that's going to be a little easier. However, using the terminal is much more powerful in that you'll have the ability to make more custom changes, and the use of the terminal may be necessary if you ever try to revert to older files. This is also possible in RStudio if we click on the history icon, where it views a history of previous commits. This will show us exactly what different types of commits we've made. You can see here that we've only created two, the initial commit and the created test.txt commit. When we click on the initial commit, you can see that we have nothing here. We can also pull on that commit. We're already up to date. So that concludes the brief introduction to GitHub, creating a repository, and also using that repository to be cloned in RStudio. There are other things that are needed to be considered, but that concludes the necessary framework that you need to understand how to use it in RStudio. As I said earlier, however, you may want to work with others on a project. You can do that by creating different branches. You can fork this, and then you can do a pull request on those forks. But if you're working in a small setting, sometimes it's easier to use a centralized workflow. You can create a centralized workflow by going to Settings, clicking on Collaborators, and then specifying using their GitHub user email address what kind of collaborator that we want to be able to give access to push and make changes to these files. When you work on group projects, one person will be creating the repository, and then that one person who created the repository will add collaborators depending on who's inside of their research project group, and then give them access to make pushes and changes to those files. Thank you, and if you have any questions, as always, please don't hesitate to contact me by email or phone. Also, I highly recommend, if you have any questions or if you're really stumped and you're not able to get your answers from the questions and answers discussion board or from others on the discussion board, to go ahead and email me and make a Zoom meeting. As a reminder, my Zoom meetings are on Wednesdays from 9 a.m. to 11 a.m. Thank you very much, and enjoy this week of learning.